Hello, welcome back to the LOOC. In this segment, we are going to look at instance variables that are floating point number types or decimal types, as opposed to the string types that we saw in our previous gradebook application. The native types float and double are jointly called floating point types. Their name comes from the decimal point that can kind of move depending on how many decimals we want. So it kind of floats within the number. And C# treats all real numbers as double by default. A double type variable has a higher precision than a plain floating float or floating point type variable. And in addition, we have the decimal type variables where we have to indicate the type with the letter M, capital or lowercase, which stands for money. The class named account that we are going to write here shows the process of maintaining the balance of a bank account. And then we create two accounts and we are going to initialize them with decimal literals, one of them being incorrect, being negative. So here is the actual class account. Has a constructor using a decimal type as an initial balance. We set the balance to that, and has a method public credit in which we increase the balance, and the balance itself is a private decimal in the first line, a private decimal instance variable. This instance variable, I don't know why that's coming up. This instance variable is handled by a public property called balance with a capital B, which has a set and get method as we've seen it before. It also has an error checking part of the code. It checks that only a positive balance can be set. We're going to test the account with an account test code, creating two accounts and putting different amounts in them and see the output after that. So let's try to do this. Here is our project, account application, and our class is called account. It's a public class account. The public in front of the class name means that the class that we are defining here is accessible to any other application code. It's not limited only to the current application's code. This is important because otherwise classes are internal types, so internal versus public. And generally we want to use public classes. So within our class we create I don't know what was that about. We create let's start with the we create a private decimal member called balance, lowercase balance, and by way of comment I'm noting that this is an instance variable that stores the balance, and then we create a constructor for the class. This is the initializer function that places data in instances of the class object. So it will be public, like constructors in general, has no return type, has the same name as the class, and can have an argument, a parameter plus din. In our case, we'll call it initial balance, and then comes the actual code of the constructor, and account constructor structure. What it will do, it will set the balance, which will be a property, to whatever we passed in, that is initial balance. Further methods of the class will include a method which adds credits. So credit or add an amount to the account. So public method again, void doesn't return any information, its name will be credit, and we are also going to use a decimal type for a particular amount as parameter, and this is the end method credit. And what the method does is simply increases the balance variable to the balance property by the amount that is added to it. And the function of this is to add amount to the balance, where amount is the name of a parameter. For this to work, we have to create the property to do the get and set methods. So property to get and set accessor and mutator the account balance, so it will be public and decimal as well, and being a property, capital upper camel class name, and there's a comment here, and property balance, like that. And then we can provide a get and set. This is not auto implemented, so we are creating the code. The get first and get, and what the get does is return the private balance, and the set method similarly is a mutator, and what it does is it sets the balance after validation. So first validate that value is greater than or equal to 0, and if it is not, balance is left unchanged. So this code is carried out using an if conditional statement. If value is greater than equal than 0, then we go ahead. So balance equals the value keyword, which is the implicit argument passed in the set method. Otherwise we do no change. So that will end the property balance, and that will end our class account. So fully shown in code, here is our class account. So there's a private instance variable that stores the balance. There's a public constructor, a public method to add an amount to the balance, and a private balance with the get and set methods provided by us, the programmer, and not auto-implemented. Now we have to create the account test, the test program that is going to use this class account. That is the class with the main method in it. Public class account test, and the main method is where the application begins. So within the main method, actually I wanted to place this comment not here but on top of it, to be honest. So within the method, the main method, we create we create two instances of the account class. Account, let's call it account 1. We need to create a new keyword and call the constructor, already dropping down, and put some amount in it, in our case 50, corresponding to dollars, so 50M, and that's create account object number 1, and the same thing, so I'm just copying this code. Have to select it first and then control copy, control V2. This will be account 2, and this will similarly place in amounts, but that will be an incorrect one, so 753. So we create it like that, and with that we are ready to write code that will display initial balance of each object using a property. So it will be console dot write line and we are going to write that account 1 balance, and a format string that is similar to what we've seen holding a parameter for a content string, but not just holding a parameter but specifying a format, in this case C, which stands for currency, and the content that we are going to display is actually should have finished the string there, so it was warning me all along. So account 1 dot balance, that's the first display, balance property, and the second one is the same line for the second account. So this will be account 2 balance, is the only difference, and other than that it's the same line. So if we can stop here and check if our program is correct. Let's comment the code blocks. So this is the end of the main method, and then we see the end of end class account test. So, and then end of our namespace in this file. So we can save that, and let's build a solution. There's no error, then with Control F5 we can run it, and it will display the amounts we created, even though in case of the second one we started with a negative balance as a test, which is kind of incorrect, but we allowed that as per the constructor, and it is displayed in parentheses. So this shows that the :C format string works properly for currency values. So let's continue writing our main method. Let's use a local variable called deposit amount. So this is a variable that we are going to use to find a deposit amount read from the user, and the way we are going to use that is that first we prompt the user and obtain the user input. So this is as we are used to. It will be a console write, because it's a prompt. So enter deposit amount for account 1 and space. This will pause on the console line, in the middle of a line, waiting for an input, which we are going to receive as deposit amount being equal, and this is a read line but needs to be converted. Converted to decimal. Could be 2 double, 2 datetime, but we are using 2 decimal. And now we have to read from the console and read a line. So this will read the amount as well as convert it to a decimal value. And now we can indicate the user that we are adding this amount. So it will be a write line, since it's a full message. So adding, indicating what in currency format with a format string to account 1 balance, and the new line character, and deposit amount. That's what we want to accomplish. And following that, we want to actually add the account. So account 1 dot credit, and we want to credit the deposit amount to account 1, so that we don't just write so, but we actually do it. Let's do the same thing for account 2. Before we do that, actually, let's display the balances for both accounts. So display balances, and this will be console write lines. As a string, account 1 balance, and colon, and let's indicate what and in what format, and what we are adding is in what format, end of string, and we add what we want, which is account 1 balance, using the property balance, which is available because it's public. Implicitly calls the get accessor, and the second line we do the same thing for account 2. So we just have to modify the name of the account to account 2, and we can save all this, and with Ctrl F run it, which will recompile the code. And so at this point we are where we were before. Try to reduce here the window so that the code is visible, and suppose we add something to the first amount, so $49.99, and in response the code will display that we are adding $49.99 to account 1. In response, the balance of account 1 changes to from 50 to $99.99. So that completes that part, and then we can handle the account 2 the same way. So I'm going to copy the code because it takes only modification, it's not really brand new. So deposit for account 2, and using the deposit amount, and indeed we are going to do the same thing for account 2, and then we can display the balances again. Ctrl C for copy and Ctrl V to paste. So that will complete the code for the second account. So fully showing it, say as a class, account test class, here is the code, you can save it, and Ctrl F5 will recompile and run the code like that. Try to pull it down closer in the corner. So let's enter some amount for account 1, $49.99. Enter that. So it's adding that to the balance, making it $99.99. Meanwhile, the second account is still negative $753. So let's add some amount to that, such as 123.21 to account 2, and our accounts will then display the closing account. So that's our code. So It's somewhat weird because we allow the negative amount as an initial deposit. A somewhat more consistent code would be shown if we open the second account only as with an amount of 0, in which case in Ctrl F5 we rerun the code, and reducing that window to be able to show it together with the code. So if in account 1 again I am placing $49.99, then it appears with a balance of $99.99. Meanwhile, for the second one, if I now place 123.21 as a possible amount, then I end up with that amount in the second account. So that's the output, and again here is the code for the account class, and the get and set for the balance property, and the account test class adding balance to an account. The difference from our gradebook class that in this case an instance variable has a decimal value, which is a form of floating point, instead of a textual value like the gradebook had. So that's the output that we expected, and we use there the curly braces 0:C format specifier, where the character C specifies a format, can be uppercase or lowercase c to indicate currency, upper or lowercase d for integers, upper and lowercase n for decimals with thousands, upper or lowercase e for scientific notation, F for F with a fixed decimal place value 2 being the default, capital G or lowercase with scientific notation with decimal places, and X, uppercase or lowercase x for hexadecimal numbers. A comment that accessors and mutators can have different access modifiers. One generally the same as the property itself, generally both of them, but we can make the set more restrictive, so the get might be public, but the mutator can be private because it called only within the class itself. And here is our new UML class diagram for our account, which has a public property balance of type decimal. It has a constructor public account with an argument initial balance of type decimal, and a public method credit or deposit with an argument amount which is of type decimal. And that's the end of this segment, and in the next segment we continue looking at more conditional and control instructions. Bye.